Let's take a look at this example 5. A 216 square meter garden is to be enclosed by a fence and divided into two equal parts by a fence parallel to one of the sides. What dimensions for the outer rectangle will require the smallest total length of fence? Well, first of all, they gave us the area. We can see it's 216 square meters. So it looks to me like they're asking us to actually minimize the perimeter. We're going to realize that. We're going to draw a picture of what they want. So next, a rectangle would be our garden, and they want us to put a parallel fence to divide it into two equal parts. Since our area is 216 square meters, I'm going to let this side be x, my height, and my length be 216 divided by x. That way I'll have one variable. If I want to know the perimeter is normally two lengths plus two widths, but not in our picture. We have an extra piece down the middle. So our perimeter would be 2 times 216 over x for the bottom length and the top length, and then 3x's for the three pieces of fence that go in this direction, which are vertical in my picture. Now you do not want to take the derivative here. You have a product, you want to multiply those together first. Now that we have our primary equation, if we take the derivative, thinking of 432 over x is 432x to the negative 1. When we take the derivative, we'll have negative 432 over x squared plus 3. Setting it equal to 0 and moving the negative 432 over x squared to the other side, cross multiplying, we find out that x is 12. If x is 12, we could take 216 and divide by 12 and find the other dimension to be 18. But is this a max or a min? Taking the second derivative, we see we would get a positive 2 times 432 over x to the third, which is always positive. Therefore, p at 12 is concave up. At the critical point, it would be a min. The dimensions would be 12 by 18 meters. Is that what they asked us for? They said, what are the dimensions of the outer rectangle that require the smallest length of fence? It is. So let's see if we followed all the steps. Did we assign variables and draw a picture? Come up with a primary equation simplified to be maximized or minimized by taking the derivative? Did we take the derivative of the primary equation, set it equal to 0? Is our solution within the domain of the problem? If we came out with something so high that when we multiplied the length and the width, we got something greater than 216, that would make no sense. But it is within the boundaries, because if we figure out the perimeter and the area, it comes out to 432 for the area. Did we justify by calculus that it was a min? Yes, we did. There'll probably be a problem like this on the test, but I could switch these two. I could give you the perimeter and ask you to maximize or minimize the area. So watch out what's given. You're never going to maximize or minimize the given. You're going to maximize or minimize what they ask you to determine the max or min of.